Matter is anything that has mass and takes up space within our universe, but matter actually only composes less than 5% of our universe. In fact, there's another form of matter, dark matter, that composes 27% of our universe. But what is dark matter, and why do we know that it exists? It's all due to math.
Just like planets orbit around the sun or a star in our own solar system, stars orbit around the center of a galaxy due to two forces. The first is Newton's law of gravitation, which defines the gravitational force acting on a star. This is force equals the gravitational constant times the mass within the orbit times the mass of the star over the radius of the star's orbit squared, which is essentially the distance from the center of the galaxy to the star. The second equation is centripetal force, which is the force that allows the star to follow a circular path around the center of the galaxy. This is defined as force equals the mass of the star times the orbital velocity squared, so how fast it's moving, over the radius of the star's orbit. In galaxies, these two forces equal each other, which allows the star to stay within orbit of the galaxy and not simply fly off into nowhere. So this means that we can put these two equations together. When we set them equal to each other and do a few cancellations, we end up with our orbital velocity of our star squared is going to be equal to our gravitational constant times the mass within the orbit of the star over the radius. So what does this mean? Well, this means that since our radius is on the bottom of the fraction, as it gets bigger or the distance away from our galactic center increases, our velocity is going to decrease. So when we look at a galaxy, what should we expect? Well, let's say we have two stars orbiting around our galactic center. Star 1 is closer to the center, so it has a shorter radius, while star 2 is farther from the center, so it has a larger radius. Based on this equation, we should expect that star 1 has a faster velocity than star 2 because star 1 has a smaller radius.
But this is not exactly what we see. For example, in 1980, astronomer Rubin saw that stars at the edge of 21 spiral galaxies were moving at the same velocity as stars closer to the center of those galaxies, which doesn't really align with the math we just talked about. So why could this be? Well, since g is constant, the only explanation of this leveling off of velocity has to do with the mass. So one suggestion was that as we move further away from the center of the galaxy, we take up more mass in terms of gas and dust and stars. However, the amount of mass we're taking up in terms of gas, dust, and stars doesn't account for the leveling off of velocity that we see. We would need much more mass. So there is some other mysterious amount of mass that we cannot see, and we call this dark matter. So what is dark matter then? Well, we're not quite sure. We know that it has mass and takes up space, but dark matter doesn't reflect, absorb, or emit light. What we do know, however, is dark matter takes up a majority of a galaxy's mass and is super important in facilitating the way that galaxies are organized, making it a very important area for future scientific research.